Hello everyone, how are you all? I am Sunakshi, your mathematics teacher for today. Today we will do your chapter 12 of NCERT, which is Exponents and Powers. In this we will do all the laws of exponents with negative powers, and also we will do use of exponents to write down very large numbers and very small numbers in the form of standard form. So let's start with today's topic, that is exponents and powers. Exponents. What are exponents and powers? You have already done in class 7 this particular chapter, exponents and powers. For example, 2 raised to the power 5. What is 2 raised to the power 5? It is 2 multiplied by 2 multiplied by 2 5 times, means 32. In this, 2 is your base and 5 is your exponent. But in class 7, we have done this thing only with the exponents with positive integers. Now, in class 8, we will do all these with negative powers. For example, if you have, in place of 2 raised to the power 5, we have 2 raised to the power minus 5. Then how to solve it? Remember one thing, whenever the power is negative, first of all, we have to make it positive. How to make it positive is, to make it positive, only we need to do is to do reciprocal of the base. The main thing is to do the reciprocal of the base. So now what is reciprocal of 2? We all know that reciprocal of 2 is 1 by 2. That means it will be 1 by 2 raised to the power 5. So whenever power is negative, our answer to convert it into positive only to do is to do the reciprocal of the base. Let's take one more example. We have 10 raised to the power minus 2. So to remove negative sign from the power, what we need to do is to do the reciprocal. Reciprocal of 10 is 1 by 10 and power will become positive now. So power will be 2, 1 by 10 square or 1 by 10 into 10. So your answer will be 1 by 100. Negative power means it will be 1/10th, 100th, 1000th, like that. Now, all of you have done how to write down any number in expanded form using exponents. Like you have already done in 7th class to write down 1425 in expanded form using exponents. Like, for example, 1425, how we can write down? It is 1 into 1000 plus 4 into 100 plus 2 into 10 plus 5 into 1. So if we have to write down in the form of exponent, it will be 1 into 1000 means 10 raised to the power 3. 100 means 10 raised to the power 2. Only 10 means 10 raised to the power 1. And 1 means 10 raised to the power 0. All of you know that any number power 0 is always equal to 1. Any number, whether it is 2 raised to the power 0, whether it is 3 raised to the power 0, whether it is 100 raised to the power 0. So any number power 0 is always equal to 1. So whichever number we can write down over there. So this you have already done in 7th class. But if we have the number in decimal form, for example, 1425.36, and they will tell you to write down this in expanded form using exponents. So till here it will be exactly same, means 1 into 10 cube plus 4 into 10 square plus 2 into 10 raised to the power 1 plus 5 into 10 raised to the power 0 plus. Now, here comes decimal. All of you know that after decimal, your terms will be 1/10th, 100th, 1000th, like that. That means what we will write down? 3 into 10 raised to the power minus 1 plus 6 into 10 raised to the power minus 2. If one more number will be there, then that number into 10 raised to the power minus 3, and so on. So whenever decimal is there, after decimal, your exponents will always be negative. With first number, 10 raised to the power minus 1, with second number 10 raised to the power minus 2, with third number 10 raised to the power minus 3, and so on. Let's take one more example, then we'll move further. For example, let's take 2356.723. Now, 2356.723, write down this in expanded form using exponents. Now, so that means it will be 2 multiplied by how many numbers? 3. So 10 raised to the power 3 plus 3 multiplied by, after 3 how many numbers? 2. So 10 raised to the power 2 plus 5 into, after 5 how many numbers? Only 1. So 10 raised to the power 1 plus 6 multiplied by, no number after 6 before decimal. So 10 raised to the power 0. No number means 10 raised to the power 0 plus point. Now decimal starts. So after decimal, your powers are always negative. So that means 7 into first number. So 10 raised to power minus 1. Second number, 10 raised to the power minus 2 plus third number. So it will be 10 raised to the power minus 3. So that is your answer in expanded form. I think till here it is clear to you people what we have done, how to write down with negative exponent into positive number, and how to write down the number with decimal in expanded form. Let's move further. We'll start with laws of exponents. All of you have done laws of exponents in 7th class also. But in 7th class, you have done all the laws of exponents only with positive powers. Like, let me share the exponents with you, laws with you first. Laws of exponents. Which were the laws of exponents? First was a raised to the power m multiply by a raised to the power n is equal to, what was it? Base same, multiply sign, powers will be added. That means a raised to the power m plus n. Similarly, base same, divide sign. Base same, divide sign, powers will be subtracted, m minus n. If base are different but the power is same, then what to do is we'll multiply the bases and power will be outside. A into b power m. What if we have in between of multiply we have divide, a raised to the power m divided by b raised to the power m. So again same thing, a over b and power will be outside. And what if two powers are together? A raised to the power m, outside we have n. So what was it? A raised to the power m multiplied by n. So all these laws of exponents you have already done in 7th class, but in 7th class all the powers were there with all the powers were only natural numbers. Now in this class we need to try these laws. We need to check whether these laws will hold if these powers are negative or not. Let's explore this. Let's prove this by taking any one example for any law of the exponent. Then it will hold for each and every law. So let's start. 2 raised to the power minus 3 multiplied by 2 raised to the power minus 2. According to this, it should be power should be added. But let's check whether it is true for that or not. So what we will do? First of all, we will make the powers positive. Right now, I have explained you how to make the power positive, how to make it to reciprocal the base. So now to reciprocate the base, reciprocal of 2 is 1 by 2. So it will be 1 by 2 raised to the power 3. Similarly, 2 raised to the power minus 2 will become 1 by 2 raised to the power 2. So now it is 1 by 2 raised to the power 3 into 2 raised to the power 2. Now base same, multiply sign, and powers are natural numbers, so we can add them. 1 by 2 raised to the power 3 plus 2. So we have got 1 by 2 raised to the power 5. And how to write down as 1 by 2 raised to the power 5? We can write down it as 2 raised to the power minus 5. Also, you can check that sum of this minus 3 and minus 2. Minus 3 plus minus 2 is also minus 5. That means we have proved that this law holds for negative powers also. That means all the laws of exponent holds for negative powers also, means a raised to the power m into a raised to the power n is equal to a raised to the power m plus n, where m and n are integers we can write down. That means they can be positive numbers also, there can be negative numbers also. So I think this will be clear to you people. So let's do one example with this, with any other law. Let's take one more example. It is 3 raised to the power minus 5 divided by 3 raised to the power minus 2. Now, right now I have told you that base same, multiply sign, powers will be added. Now base same, divided sign, powers will be subtracted. That means 3 raised to the power minus 5, subtracted means minus sign now and the next number. So now 3 raised to the power minus 5, minus minus plus. So it will be 3 raised to the power plus minus minus. So minus 5 plus 2 is minus 3. So answer is 3 raised to the power minus 3, or you can write down it as 1 by 3 raised to the power 3. That is your answer. Means we need to apply all the same laws which you have done in your 7th class with positive powers. Now in this class we will do all these with negative powers. So let's take one more example to prove the law. So that is anyone, like we have 2 raised to the power 5 multiply by 3 raised to the power 5. Now which law holds for this? A raised to the power m multiply by b raised to the power m. Means if the power is same, the base will be multiplied. That means 2 multiply by 3 and the power will be outside. So your answer will be 6 raised to the power 5. Same you can do if the power is negative. Means in place of plus, if we have negative, means 2 raised to the power minus 5 and 3 raised to the power minus 5. So again same, 2 into 3 power minus 5. So our answer will be 6 raised to the power minus 5. So your law proves here also. That means if bases are different but the power is same, we can multiply the bases if the sign of multiplication is there, and if the sign of division is there, we'll divide the base. So let's start with your exercise questions. Simplify. The question is simplify and express the result in the form of power only, in exponents only. Like 2 raised to the power 5 divided by 2 raised to the power 8 power 5 into 2 raised to the power minus 5. Let's take this. Now, let's start. Base same. First of all, we always have to solve the bracket. So now base same, divide sign. So powers will be subtracted. So it will be 2 raised to the power 5 minus 8. Do not write down it as 8 minus 5. It will always be your first number minus the second one number, whichever power is first. Outside it is 5 and into 2 raised to the power minus 5. 5 minus 8 minus 3. Outside we have 5 into 2 raised to the power minus 5. We have done the law. If 2 powers are there, we will multiply. So minus 3 multiplied by 5 is minus 15. So 2 raised to the power minus 15 multiply by 2 raised to the power minus 5. Now we can solve it further. How? Base same, multiply sign, powers will be added. That means 2 raised to the power minus 15 plus minus 5. So 2 raised to the power minus 15 plus minus minus 5. So 2 raised to the power minus 20 will be your answer. Or if they will tell you to write down the answer in positive exponent, then we can leave the answer in positive exponent. All of you know that to convert a negative power into positive, what we have to do is we have to reciprocate the base. To take reciprocal of the base, reciprocal of 2 is 1 by 2. So your answer will be 1 by 2 raised to the power 20. This we will convert if they will ask to write down the result in positive exponent. Otherwise, you can leave the answer till here also. I think this sum is very much clear to you people. Let's take one more example from your exercise only. Now, we have done that if two base are different and the power is same, we can multiply. Let's try it with the 3. For example, 4 raised to the power minus 3 multiply by minus 5 raised to the power minus 3 multiply by minus 2 raised to the power minus 3. Now, you can see that all the powers are same. So, a raised to the power m multiply by b raised to the power n. We can take into c raised to the power anything x like that. So, whenever you can do it directly also. If the power is same, we can write down the power outside and we will multiply the base if multiplication sign is there. So 4 multiply by minus 5 multiply by minus 2. So it will be 4 into 5 minus 20 multiply by minus 2 and the power outside is minus 3. So minus 20 into minus 2. Minus 40 or 40? It will be 40 because minus minus will become plus. So it will be 40 raised to the power minus 3. That will be your answer. But if they say to write down the answer in positive exponent, then how to write down? We will write down 40 as 1 by 40 raised to the power 3 to make the power positive. So that will be your answer. I think this thing is also clear to you people. Let's take one more example where power is 0 given. 3 raised to the power 0 plus, this is your exercise question, plus 4 raised to the power minus 1 multiply by 2 raised to the power 2. Let's solve this. I have told you in the starting only, any number power 0 is always 1. So 3 raised to the power 0 means 1 plus 4 raised to the power minus 1. First of all, we'll convert the power into positive. So any number, any power to convert it into positive, we have to take reciprocal of the base. So 4 will become 1 by 4 multiply by 2 raised to the power 2 is as it is. Now, all of you have done how to add these numbers. 1 plus 1 by 4. Take LCM. 4 will be LCM. So it will be 4 plus 1 in the numerator into 2 square. 5 by 4 into 2 square. 2 square means 2 multiply by 2, which is also 4. So our answer is 5. So what we have done? Only we have simplified anything power 0, 1. Negative power was there, so we have converted into positive. It will become 1 by 4. Solve the bracket first. We have taken LCM. So 4 plus 1. 5 by 4 into 2 square, that is also 4. So 5 by 4 multiply by 4, our answer is 5. Now, let's take one example where you need to find out the missing value. For example, they can give you find the value of m so that minus 3 raised to the power m plus 1 multiply by minus 3 raised to the power 5 is equal to minus 3 raised to the power 7. Now, they said find this missing value m. Now, how to find it out? We'll apply same laws here. You can see that base same, multiply sign, so powers will be added. That means minus 3 raised to the power m plus 1 plus 5, and right hand side will be exactly same. So minus 3 raised to the power m plus 1 plus 5 is 6 is equal to minus 3 raised to the power 7. Both are equal means you can check that. Is equal to sign means left hand side and right hand side are equal. We can equate only if its base is same. So you can check that. Their base are same. That means we can equate their powers also. Means m plus 6 will also be equal to 7. So m will be 7 plus 6. When we shift to that side, it will become minus 6. So m is equal to 1 is your answer. So what we have done? Only we have applied the laws of exponent, multiply sign, so powers added. After adding, only we will compare. Now you can check if base is same, then only we can compare. Base same, so we can compare their powers also. So m is equal to 7 minus 6, that is m is equal to 1. You can get this question where in place of this multiply, you can get a negative sign. For example, 5 raised to the power m divided by 5 raised to the power minus 8 is equal to 5 raised to the power 6, suppose. Now, again you can check that. Base same, divide sign, so powers will be subtracted. That means 5 raised to the power m minus 8, and that is 5 raised to the power 6. 5 raised to the power m plus 8 is equal to 5 raised to the power 6. Again, base are same, so we can compare the power. So that means m is equal to 6 minus 8. That means value of m is minus 2. So that means m is equal to minus 2 is your answer. So I think we have applied all the laws of exponents in different forms. Based on this, you can complete your first exercise. Now, only one topic is left in this particular chapter, that is use of exponents to write down very large numbers and very small numbers in standard form. All of you have already done in 7th class how to write down very large numbers in standard form. I'll give you an example. For example, you have already done that mass of Earth is 970, 1, 2, 3, 6, 7, 8, 9. Now, this one kgs. This much large number you have to write down easily in standard form. Standard form means after first number a decimal should be there. Now, here the number, not, it should be a natural number. So that means 5.97. Till numbers will write down. Remaining zeros will write down in the form of 10 raised to the power. You have already done in your 7th class. Now check. We have written from here decimal. So how many numbers are there after decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that means 5.97 into 10 raised to the power 21 kgs is your answer. This is the easiest way, or this is the standard form to write down a large number in exponential form. I'll tell you the method to write down very small number and very large number easily in standard form. What is that method? That is very easy way. I'll tell you that. Suppose by taking two examples. For example, you have 6, 2, 3, 5, 1, 2, 3, 4, 5, 6, 7, 8. This is the number. And one example where we have 0.00000000007. This is there. These are the two examples. They said write down this in exponential form or in standard form. Now, standard form I said to write down after first decimal. This number is there. That means here is the decimal and after that is zeros. So whenever you are shifting decimal to left hand side. Now, from here we are shifting the decimal to left hand side. We are shifting decimal here 6.235. You are shifting decimal here. So count the in between numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 numbers are there in between. So it will be 10 raised to the power 11. If we are shifting decimal from negative from your left hand side, from right to left we are shifting, your power will be positive. If you are shifting your decimal from left to right, then your power will be negative. In this, we have to, I said, to write down after first number. That means after 7 you need to put a decimal. 7.0 into 10 raised to the power. Now you are shifting your decimal here. So how many places in between? Count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 places are there in between. So that means power will be minus 10. So answer is 7.0 into 10 raised to the power minus 10. This is the easier way. What is that? If from right to left you are shifting the decimal, your power will be positive. If you are shifting from right to the left to the right, it will be power will be negative. Let's take one more example. We have 0.0000000625. They said write down the answer in standard form. Now, decimal is here. I said you need to write down in standard form. So that means after first number you have to shift the decimal. So your first natural number starts here 6. So you have to shift your decimal here. That means 6.25 into 10 raised to the power. Count the numbers in between. 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers are there in between. So 10 raised to the power minus 8. From left to right, power negative. From right to left, power positive. Let's take one more example. 0.0007893. Now, again in standard form. First number is here 7. So we need to shift our decimal from here to here. 7.893, 10 raised to the power. How many numbers are there in between? 1, 2, 3, 4, 5. So 10 raised to the power minus 5 because we are shifting from left to right. Similarly, if you are shifting from right to left, it will be positive. One example where we are shifting from right to left, like 6, 2, 3, 5, 0, 0, 0, 0, 0, 0, 0. They said write down in standard form. That means decimal in the end. So from here, we are shifting our decimal here. 6.235. Now, we are shifting decimal here. So count the numbers in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 numbers are there in between. So power will be from right to left we are shifting. So power will be positive. So 6.235 into 10 raised to the power 11. I think this topic is clear to you, where we are writing down very large numbers and very small numbers in standard form. So that was there in this whole chapter. What we have done today is to write down we have to solve all the laws of exponents with negative powers, and also we have done use of exponents to write down very large numbers and very small numbers in standard form. So I think this was all for today. This is end of this particular chapter, exponents and powers. So thank you very much all. So hope you all are doing well. Please do practice mathematics, because the only way to learn mathematics is to do mathematics. Thank you everyone.